All right, hi. In this video, I'm going to go over the answers to Algebraic Problems 3. So here we go. The kid drops a rock off a bridge. The rock falls for 3.4 seconds before hitting the water below. How far above the water is the kid? So, right down here we got our water. Oops, shoot. There's our bridge. Here's our water. So we have only downward motion here. So because we have only downward motion, we should choose down to be positive. So things that we know that the initial velocity is 0 because it says it is dropped. We know our acceleration is 9.8. It is positive 9.8 because we have chosen down to be positive. And 9.8 is going to be always down. We know that the time is 3.4 seconds. We want to choose this to be, right, why not is where the thing starts, and y is what we're looking for down there. You want to set it up so that the 0 is at the top and the number you're looking for is at the bottom, because that way, as you go, right, as it goes down, the numbers get bigger, right, because that's the positive direction. So we make the 0 at the top and the y at the bottom. So y looking for. As you look at all the variables here, because you have time and position, that's going to be the John equation. So remember to write out the John equation. Zero times by 3.4 half. You should get 56.4 meters. There you go. That's the first one. Right, because 0 times by 3.4 is 0. So make sure to do that. Next one, a tennis ball is thrown through straight up with a velocity of 12 meters per second. It goes up and comes back down and is caught at the same height as it's thrown. How long is it in the air? So it goes up, comes back down. So, right, things that we know. So it does have upward motion, so we should choose up to be positive. So let's see here. We have our initial velocity, which is 12 meters per second. That's going to be positive 12 meters per second because it is an upward velocity and up is positive. We have our acceleration, that is going to be negative 9.8 meters per second. Negative because it is a downward acceleration and we have chosen up to be positive. We are looking for time. Let's see here. We also know that, right, our initial position is 0 and our final position is also 0. So y naught is equal to 0 meters and y is also equal to 0 meters. So looking at all the stuff there, that looks like the John equation again. So then 0 is equal to 0 plus, let's see here, v naught, which is 12 t is 1/2 8 t squared. So then we have 0 is equal to 12t. That's going to be negative 4.9 t squared. Okay, so in this case, what we end up doing is you're going to pull one of the t's out. So that's going to give you 12. Hang on, sorry. And right, so this means this is basically factoring, right? So this equation would be equal to 0 when t equals 0, which would correspond to when the thing starts, and also when this second part is true. But 0 is equal to 12 minus 4.9t, 4.9t is equal to 12, t is equal to, I should put this over here just for divide by 4.9, so 12 divided by 4.9. It's going to give you 2.5 seconds. How high did it go? So, right, you know all this same stuff, except for the y is equal to 0. You wouldn't know that. So we still have the initial velocity of 12 meters per second. We still have an acceleration of negative 9.8 meters per second. We still have that y naught is equal to 0. We are now looking for y at the very top. And the other piece of information we know is that at the very top, the initial velocity is 0, right? So at the very, very top, the object is neither moving upwards nor downwards, so its velocity would be 0. So in looking at all of that information, right, we have velocities, we have acceleration, or we have velocities, we have and displacements. That's going to be the Ringo equation. There are a couple different ways to do this. So you could have done both number 2a and 2b could be solved differently than this way, but this is the way that I'm going to kind of show you. So just because you didn't do it this way doesn't mean you did it wrong. So equals 12 squared to negative 9.8 delta y. So 2 times by negative 9.8, that's going to give you 19.6. So 19.6 delta y, I'm going to move that to the other side, is equal to 12 squared is 144. Divide by 19.6, and you're going to get that delta 144 divided by 19.6, 7.35. Sorry, I've been weird about my rounding. You could have rounded it to just 7.3 if you'd wanted to. Meters. So there you go. Next one. An astronaut on a new planet drops a rock 20 meters off a 20-meter tall cliff. It takes 2.5 seconds to hit the ground. What is the acceleration on the new planet? So let's see here. Same kind of deal. Basic setup as number 1. Right, the object starts here, so we'll call that y naught is equal to 0. You only have downward motion, so we should call that direction the positive direction. We know that we would say that this is equal to 20. That's our rock, by the way. 20 meters. That way, right, because down is positive, so you want your positions to get bigger as you go downwards. We also know that our acceleration would be positive 9.8 because we have chosen down to be positive. Our initial velocity would be 0 because it was released from rest, and we are looking for the acceleration. So as same deal as number 1, you're going to use the John equation again. So that's going to give you 20 is equal to 0 plus 0. Oh, and shoot, sorry, you also know that t is equal to 2.5 seconds. Sorry about that. Oops, not 9.8. We don't know that. That's what we're looking for. Sorry about that. Okay, so 20 is equal to, right, those two things are going to go away. 2.5 squared times by 0.5 is going to give you 3.125. Divide by 3.125. You're going to get that your acceleration is 6.4. There you go. Next one, your friend is standing 8 meters below you, below your window, talking loudly on the phone. You throw a water balloon out a window, straight down with a velocity of 3 meters per second. How fast is the balloon traveling when it hits them? So, same kind of same kind of setup as 1 and 4, except that it does have an initial velocity this time. V naught is equal to 3 meters per second. So it's thrown downward with a velocity of 3 meters per second. You do have only downward motion here. So we will say that y naught is equal to 0 and y is equal to 8 meters. Again, because you need down to be the positive direction. So let's see here. We know that v naught is equal to 3 meters per second. It is positive, right? It's a downward velocity, but it's positive because we chose down to be the positive direction. We also have an acceleration of positive 9.8. Again, it's a downward acceleration, so that's why it's positive. We know that y naught is equal to 0 meters. We know that y is 8 meters. And we are looking for the final velocity. Note we aren't given time. We're not asked to find time. So therefore, we have a final velocity and a distance. The one that has a displacement or distance and a final velocity is the Ringo equation. So there we go. Two times by 9.8 times by 8 is going to be 156.8. Come on. Plus 9, 165.8. So then square root, v is equal to square root of 165 is going to be 12.8, 12.9 meters per second. Once you've rounded, 12.9 meters per second. And here we go. Number 5. Two painters are painting a house. One is standing on the ground and tosses a roll of tape up to the other one. So on the ground, it's going to go up to the other guy. And the tape is thrown, so it just reaches the highest point. So what was the initial velocity? Okay, so we know that the final velocity is 0 because right when it reaches the highest point, right, that tells us that the final velocity is 0. We know that our acceleration, sorry, I'm getting ahead of myself here. We do have upward motion, so we should choose up to be positive. So that means our acceleration is negative 9.8. We are looking for an initial velocity, and we know that, right, so y naught is down here. We'll call that 0, and y is 7 meters. So y naught 0 meters, and y is equal to 7 meters. And so looking at all the stuff, we're going to be looking at the Ringo equation again. So that's going to be let's see here. Final velocity is 0 squared is equal to initial. Sorry, we're looking at. Oh, initial is what I'm looking for. So p naught squared plus 2 negative 9.87. So 0 is equal to squared plus 2 times by negative 9.8 times by 7. It's going to give me a negative 137.2. Add that to the other side. So 137.2 is equal to v naught squared. Square root both sides. And v naught is equal to square root of 137. And you should get 11.7 meters per second. All right, next up, how long was it in the air for? Pretty much we know all the same information as well as the initial velocity. Probably the easiest thing here to do is to just use the John equation or the Paul equation. So final velocity is 0. The initial velocity was the 17.7. Acceleration is still negative 9.8. And we're looking for t. So 9.8 t is equal to 11.7. So divide by 9.8. 11.7 divided by 9.8. It's going to give you 1.2 seconds. It's a heck of a throw. Okay, one last one. If I can get it done here before my pen dies. You are standing on top of a cliff. You throw a rock upwards. Ooh, we haven't had one of those yet. Throws it upwards and it lands down below. It's in the air for 4 seconds. How tall is the cliff? So we do have upward and downward motion, so you should choose up to be positive. So your initial velocity is 12 meters per second. Your time is 4 seconds. Our acceleration is negative 9.8 because it is a downward motion. What else do we have? This is why not. That's what we're looking for. And right, we land down here at 0. Looking at all that stuff, right, that's going to be the Paul or the John equation. So 12 times by 4, 36, 48. Nope, yep. 48. We got 0.5 times by 9.8 times by 4 squared. It's going to give you negative 70 because of the negative sign and then 9.8, negative 98 or 78, sorry, 0.4. We can then combine those two. So, oops, 48 minus 78.4. So we have 0 is equal to y naught minus 30.4. So y naught equals 30.4, right, added to the other side. And then you get y naught is equal to 30.4. And there you go. That's the height of the cliff. All right. Well, thanks for watching. Hope this helps.